Hello everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivered for a subject Microcontroller and Embedded Systems Design having code KECU 061, what we have completed? We have completed unit number first, and after that we have started the unit number 2. It is all about the MSP 430. In our previous lecture, we have discussed a lot about the MSP 430. So, we will left our last topic of MSP 430, that is unit 2 is interrupt and its programming. So, in this lecture we will discuss the remaining topic of the unit 2, that is interrupt and its programming. So, these are the table of contents we will learn in this lecture. First is the introduction to interrupt, because we are dealing with the interrupt, we need to know what is the interrupt, concept of interrupt we need to clear. So, after that we will discuss what is the difference between interrupt versus polling. There is another method available, polling. So, what is the difference between interrupt and polling, we will discuss. After that we will see some examples of interrupt, okay, real life examples of interrupt. After that we will discuss the interrupt process, how the process will occur in our interrupt system. After that we will discuss the interrupt flag, we will discuss the interrupt service routine, that is the ISR we will discuss here, okay, and how steps for process and interrupt request. If any interrupt occur, how we can process its request, we will discuss here. After that we will see some programming techniques of interrupt, and the last slide we will discuss the applications of interrupt. These are the table of contents. So, let us start with the first, what is interrupt. What is interrupt? In any microprocessor or microcontroller, interrupt is present. Basically, is the disturbance signal, we can say that. For example, if we are watching a movie and our parents told us that you need to go to the market, or either you need to go to market or stop watching movie and you have to play, you have to read you have to complete your homework. So, what will you do? You will whatever you are doing, you will stop and go to the instruction told by your parents. So, the parents instruction is like an interrupt signal. Whatever you are doing, you will stop your current execution and go will do what according to the instructions of our parents. So, in the same way interrupt will be occur. So, basically interrupt is a signal that informs our microcontroller unit, MCU means the microcontroller unit, that a certain event has happened. It means that certain event has happened, something have happened. If we are in our main program, then interrupt will tell that some event has happened. What does it event? We will discuss. So, causing the interruption of the normal flow of the program. Normal flow means that if we are working on the main program, then if any interrupt occur, it will disturb our main routine. It will interrupt our main routine. Okay. So, that's why we called it as an interrupt. It is a external signal. So, it will interrupt the normal flow of the main program, and the execution of an interrupt routine that handle the event that takes a specified action. So, it means that if we are working on in our main program, this is main program, we are writing main program. If any interrupt occur, what will happen? We will stop our main program and go to execute the particular interrupt. Okay, we will do according to the ISR of the interrupt. We will discuss what is ISR in our further slides. So, an interrupt is the occurrence of the event that causes a temporary suspension of a program. Whatever we are doing in our main program, we will suspend its current execution and will go to service the particular interrupt. Okay, we will go to service that interrupt. So, an interrupt driven system gives the illusion of doing many things simultaneously. In particular time, we can say that more than one interrupt may become. So, of course, the CPU cannot execute more than one instruction at a time. CPU didn't execute instruction. So, it can temporarily suspend execution of one program, execute another, then return to the first program. Okay. So, this concept, suspend execution, program, execute, return to the first program, we will discuss in our previous slide. This is basically the working of an interrupt. To suspend execution, to execute that interrupt and go to the go to the initial state. Whatever we have we are doing upon receiving before receiving the interrupt, we will do that again. So in a way, interrupts are like subroutines. What are the meaning of the subroutines? The subroutines are the smallest program. This is the main program, and subroutines are small programs. Interrupts will behave like this. At any particular time while executing the main program, subroutines will be called. Small programs will be called by the processor. In the same way, interrupts will causing the suspension of the main program. So interrupts are like the subroutines. Okay. So except that one does not know when the interrupt code will be executed. We do not know at what time interrupt may be occur. It may be occur at any time, anywhere in the program. Okay. This is the property of the interrupt, that it will occur at any time and any place of the program. For example, we can say that, let us take a real life example, that is microwave oven. What is the function of microwave oven? To heat something, to provide heat to particular food, anything, etc. So the main program, what is the main program in doing in our microwave system? Is to controlling the power element of the oven. In any oven there is a power element that provide heat to particular device. Here we can say that particular food. So the main program is to control the power element. What amount of heat to be applied, for how much time it will be applied, it will be task of the main program. So what we are doing with the main program. So if we press any key in the front panel, that key work as a interrupt. We are providing some interrupt values to our microwave oven. Okay. So if we press any key, it will send the interrupt signal to our main program, that is the controlling element. So the main program is interrupted. If we press key in microwave oven, whatever we are doing, main program we are executing, it will be interrupted. The main execution will be interrupted. So the ISR takes over. We will discuss in further slide what is the ISR. ISR means that interrupt service routine. Each interrupt has its own interrupt service routine, so that microcontroller finish its current execution and go to the ISR of the particular interrupt. Okay. So through interrupt we can change the cooking conditions to increase the time of the supply of the heat, and we can control our main panel through this one. Okay. So the important aspect is that whatever key we are entering, keypad we are using, it works asynchronously, asynchronous mode, not asynchronous mode. Okay. With respect to the main program. Okay. So there is some another concept, that is polling. What is meant by polling? Polling means that to poll something at regular intervals. To monitor something, poll means monitor, check something at particular intervals, or we can say that periodic fashion. So CPU monitors all several devices continuously. So if we look into the several devices continuously, then this is the concept of the polling. So polling means that to check, to monitor something in a periodic fashion at some regular intervals of time. So constantly we are checking whether there is a input or output at the microcontroller chip. Okay. So whenever it sees a request, it serves the device and then keep polling. So polling is to continuously check the input output pins of the microcontroller, if something has arrived or not. Okay. This will decrease the efficiency of the CPU. So CPU is always busy with polling, doing the while any request loop. So whatever we are doing with the CPU, it always gets busy to poll the something. So this can be applied in software to any user interface, where the microcontroller can poll the buttons to verify if there are any user inputs. So basically we can say that polling is to check constantly something, to check or to constantly we are checking the input output devices in a periodic fashion. But on the other case, in interrupts we are not constantly checking the input output pins. Interrupt will occur at any time during the program. CPU will sit in the sleep mode, and whenever any interrupt will occur, it will go into the active mode. So it didn't get continuously check the data. So in polling we are constantly check the data, but in interrupt, when it occurs, then microprocessor, microcontroller will go to service that particular interrupt. So on the other hand, here interrupts use hardware to implement a more efficient way of more efficient way means that we are not constantly checking the input output pins of any processor. Okay. So if when a device is ready, it needs attention it from the CPU. When a device is ready, it will seek the attention of the CPU. Okay. So CPU drops whatever it was doing, CPU will resume, will pause whatever it is doing, and it will go to the to service that particular interrupt. So CPU is always free through this, but the concept of interrupt, CPU is always free. It will it is not continuously check the status of the input output pins. So when not servicing an interrupt, so interrupts are essential. Interrupts are very useful to avoid wasting the processor valuable time. Okay. But in polling loops, we are waiting the lot of time of the CPU. CPU will always busy through the concept of the polling, through the concept of the polling. Okay. So in the MSP 430 architecture, there are several types of interrupts available. We will discuss that here, that there are timer interrupts, input output interrupts, ADC interrupts. So each one of them needs to be enabled or configured to work, and there is a separate service routine for every interrupt. So we will discuss the ISR in our further slides. What is ISR, how we can execute the interrupt, how it can be serviced, how we can, after servicing of the interrupt, how we can came back to the main program, we will discuss. So basically, let us consider one another example for the clear understanding of the interrupts. So basically, interrupts are like a telephone. So in telephone, there are two situations. So let us consider the first situation, that in our house, if we are expecting a call, you periodically check the status of the telephone after 5 seconds. This is like a polling. Polling means that you are constantly checking the telephone, that whether it will ring or not. That wastes your valuable time. Okay. That wastes your a lot of time to polling, that if anyone calls you in periodic fashion, means that let us say that after every 5 seconds you are polling your telephone. But in case of interrupts, if there is a ring, you can pick the mobile, you can pick your phone. So you are not polling the regularly polling the your telephone. When telephone will ring, you came to know that someone is calling you, and you will pick up your phone. CPU will be has high efficiency. It will not always busy to check that there is something happening in the GPIO input output pins of the MSP 430. This is the difference. Okay. So this is completely analogous to microcontroller. So this example is completely analogous to microcontroller. So once the microcontroller receive an interrupt request, it suspends its current execution and jump to the ISR, and once finished continues. We will see through some diagram here. So there are two types of interrupt, external interrupts and internal interrupts. As the name implies, external input interrupts mean that this is the microcontroller MSP 430 chip. External interrupts are coming from the external source to the GPIO input output pins of the MSP 430. Internal interrupts, that is already available inside the chip, already available. Okay. So for example, timers, communication units, ADC, DAC, all have interrupt units. So let us consider explain through another example, waiting for an event, family vacation. So here you can say that this is polling, this is interrupt. So if we link this example in polling and interrupt, we can find that for example, driver is driving a car, and at each step, at each particular after some time, after some 5 or 10 seconds, he will stop car, he or she will stop car and ask the passengers that, are we there yet, have you reached your destination? Some say that no, or some yes. For after 5 seconds, again it will ask to the passengers that we have reached or not. So in the same fashion, polling will work. Polling will continuously ask the processors that whether there is something happened or not, though this will waste our valuable time. But in the interrupt, if the for example, passenger A have arrived its destination, it will tell the driver that we have reached our destination and stop the car. So this will not waste the valuable time of the system. So, in the same way interrupt will occur. So, interrupt is better than the polling, because interrupt we are not polling, we are not regularly checking the status of the input output pins of the processor. Whenever the interrupt will come, MSP 430 execute it, will go to the service the that particular interrupt. Okay. So, here there is some we will see the some programming techniques of polling and interrupt. Polling means that we are continuously checking, we are polling the GPIO button, GPIO pins of the processor. Let us consider this is the GPIO, this is the MSP 430 chip, these are the input output poles, input output, I am writing again, these are the GPIO input output pins, and whenever there is so in polling it is continuously check the status of the GPIO pins through this program, in loop continuously checking the periodic fashion, polling GPIO button while GPIO underscore get input pin value, here it is continuously checking the pins status, it wastes a lot of time. So, in this case the CPU will be always loaded 100%, its efficiency will be low, it will busy all the time, CPU will be busy all the time to check the status of the input output pins. Here CPU has a very less efficiency, there is a 100% consumption of the CPU. So, it will decrease over the system performance. But in interrupts, if any interrupt will occur, it has some vector location. If any interrupt occur, then our system will toggle the output pin. Here the efficiency of the CPU is less, is greater than 0.1%. It means that CPU only look into the interrupts whenever it occurs. It will not continuously check the status of the input output pins. Okay. So, next topic is what is interrupt process, how the interrupt will occur, the process of interrupt. So, first point is interrupt preempt, disturb the normal code execution of the program. Whatever we are doing a main program, when the interrupt will occur, it will preempt, it will interrupt or disturb our normal execution of the program. For example, main code runs in the background. So, here you can see that this is the main program. So, what is a program? Program is a set of instructions. In program there are lot of instructions. We are doing instruction 1, instruction 2, instruction 3 to instruction 4 to instruction n. Okay, instruction n. So, this is a main program we are doing. Whenever the interrupt occurs, here if any interrupt occurs, then what will we do? We will stop the execution of the task of the microcontroller, whatever microcontroller doing, it will stop its current execution and it will save the contents into the some vector location, because if it will not save its current contents, then how MSP 430 microcontroller came to know that if it come into after execution of the interrupter, how it came to know that it has some contents it was doing at that time. Okay. So, if any interrupt will occur, it will stop its current execution and go to the ISR of the interrupt, save state in program counter, and after execution of the particular interrupt, it will go to its main program, it will resume its operation from where it was it has been stopped. Okay. So, this is the process. So, the interrupts can be enabled and disabled, whatever interrupts we are coming, processor can enable or disable it, it has a function. The occurrence of each interrupt is unpredictable, we cannot know that interrupt when the interrupt will occur. Interrupt will occur at any time, at any place of the program. Okay. So, interrupts are always associated with the variety of on chip, it may be a on chip, it may be external or it may be internal peripherals. So, we have discussed that there are two types of interrupt, internal interrupt, external interrupt. Okay. So, internal interrupts are timers, watchdog, D to A converter, accelerometer, etc. So, interrupts are commonly used for urgent tasks, whatever we are doing it is used for urgent tasks which are highest priority than the main code. So, basically urgent task mean that whatever we are doing main program, if any other program need attention, has higher priority than the main program, then it will execute through the concept of interrupt. Okay. So, this through this slide we can get the more details of the interrupt process, how do interrupt work. So if we are doing our main program here, if any interrupt occurs, what will happen? Interrupt may be occur in any through UART, GPIO pin, timers, A to D converter, etc. If any interrupt occur, then its associated flag will be high. Flag will indicate that interrupt has been occurred in the main program. This is the indication. So flag give us the indication that something has occurred, and basically for that the associated flag will be high. So interrupt flag registers, it will be high. After that, CPU acknowledge interrupt by current instruction completes. After execution of the interrupt, whatever we are doing, it will save the contents into the program counter, okay. Save the content into the status register. So clear most of the SR which turns off the interrupt globally. So we have to disable the GIE, global interrupt enable, and determine the INT source, from where INT source is coming, and read interrupt vector, okay. So after getting the interrupt, it will go to the ISR from the interrupt. So basically what is ISR? ISR means the menu, it's like a menu or it's like a protocols. So whatever to do with the interrupt, it will be tell by the ISR, interrupt service routine. What the routine has to be followed after executing the interrupts by the processor. So save contents of system. If group INT read its registers value, run interrupt code, and after execution of the interrupt, after servicing the interrupt, the program whatever we are doing, we will go to the its initial value, okay. So this is the process of the interrupt. So first point is interrupt will occur at any time. If the interrupt will occur, the processor will stop whatever it is doing. It will save the contents into SR, status register, and start to servicing the interrupt, and after the interrupt has been executed, it will return, the processor will return to the main program through using some interrupt. This is the program steps, okay. So here we can see that this is the user program we are doing with the main program, 16-bit values, but whenever the interrupt will occur, okay, the processor will save its contents and go to the ISR of the interrupt, and after executing the interrupt, it will again go to its main program using return RET, return I. I means that in return interrupt instructions. So how we can control the interrupt? Through some software programming. So lookup interrupt here, store information into SC, transfer to go to the interrupt service routine, restore information, return from the value. These are the programming concepts, okay. So next point is the interrupt flags. What is the interrupt flag? We have seen that if an interrupt occur, it will acknowledge by the flag. So for if any interrupt occur, the flag will be raised. Raised means set 1 or reset means 0. So when the interrupt occur, the associated flag will be high. That means it has a value of 1. For example, timer A set the TAIFG value in the TACTL register when the counter TR returns to 0. So its associated flag will be raised. Each interrupt flag has a corresponding enable bit. Setting this bit allows the hardware module to request an interrupt. So interrupts are both maskable and non-maskable. Maskable means that which can be disabled. So interrupts at any time, if the processor receives the interrupt, it can disable or enable the interrupt. They can be maskable, they can be non-maskable, okay. So unlike subroutines, ISR can execute at unpredictable times. We cannot know when the interrupts will occur at the main program. Must return using, so we can return through RET, or RET means return, or return I instruction, return I, okay. So what is interrupt service routine? We can see that ISR basically the like a set of protocols, set of values to execute the interrupt. So interrupt service routine tells the microprocessor that what to deal, how to deal with the interrupts, upon receiving by the instruction, okay. So it can occur at unpredictable times. So basically it is like a set of protocols, set of rules, and each it has a so each ISR has its vector address, okay. So basically this is like a menu or table of contents which tells the processor that how to deal with the interrupts. The CPU must know where to fetch the next instruction. So MSP uses vector interrupt. Vector means that each interrupts are coming, it has a vector location, some memory location in the lookup table of the ISR. Each ISR has a lookup table, and each lookup table has some entries, and it has a address. So we can call it vector interrupt. Okay. So vector table is a fixed location. So each ISR has a vector table. This is vector table. Each vector table has some memory location from where we can execute the interrupt. So these are the steps for what are the various steps. Currently executing instruction is completed upon receiving the interrupt by the main program. Main program currently execution instruction will be completed, and the CPU was active when the interrupt was requested. It means that CPU will be in the off state when the interrupt is coming. CPU will be enabled by the M clock. Okay. So we will save the contents into the stack SR register. Okay. The interrupt with the highest priority. If any particular moment multiple interrupts can come, each interrupt have priority. Okay. So the interrupt with the highest priority, for example, if we are doing any task, we have to read or we have to play. So the priority will be to read the contents. So it means that if multiple interrupts are coming at particular time, so the CPU has a feature that it can disable or enable particular interrupt. So the interrupt with the highest priority will be executed by the processor. So each interrupt for particular interrupt, its associated flag will be raised. Okay. And the SR is cleared. After that, we are pushing the contents into SR, and we have to clear it. Okay. And after executing the interrupts, the CPU will come to its initial value. So let us consider through some interrupt programming. This is the programming to toggling the LED. First we will stop the watchdog timer, because while programming, watchdog timer can reset or restart the system. For precautionary measure, we have to stop the watchdog timer. We will use P1.6 port 1 6 pin as an output pin, because we have to connect the LEDs. So LED will configure in the P1.3 port as well. So after that, we have to disable the global interrupt. We will work on the LPM. 4 LPM is low power mode bits, and after that we will check if there is interrupt occurred. If not, then okay. If interrupt occur, then we will toggle the LED at P1.6. This is the flow chart, and this is program associated with it. We will use the header files. This is a set of libraries set of libraries used for embedded C programming. We will stop the watchdog timer. We will disable the watchdog timer. We will configure our LEDs in P1.0 and P1.6. We will invert the bit, because LED is connected. LED1 is connected to P1.0 and LED2 connected to P1.6. We will set the direction. We will enable pull up down registers through this. After that, we will clear the values. Okay, and enable interrupt for P1.3 here, and we will check end up for that particular LED, the flag will be raised. Okay, and after that the program will go into the low power mode 4. Okay, and after executing the interrupts, we will return to the main program. Okay, and each interrupt has some vector location. If this is ISR, and each ISR has its vector location, and it has associated address with it. So pragma vector means that vector interrupt. Vector means that each interrupt has its some known location from where it is coming, and we will after that we will check that P1 IFG is set or not. After that, after satisfying these conditions, we will toggle the P1.0. How we can do that? We will use this sign. This means that toggle, and this means invert. So we will use this sign to toggle the LED. After that, P1 IFG, we again clear the interrupt flag. Okay. So in last slide, we will discuss what are the various applications of interrupt. Interrupts are used to do complete urgent task. If any urgent task is needed, so we will stop our main program and start to execute the interrupts. At particular time, it may occur that some program, some task has more at highest priority than the main program. Infrequent tasks such as handling slow input from humans, where we use interrupts, and we want to we not overhead the regular polling. So, so interrupt has more advantage than the polling we have discussed in our previous slides. So, waking the CPU from sleep, if CPU in the sleep mode, then to go into the active mode we will use the concept of interrupts. So, to call an operating system, if we want to operate any operating system, then we use the concept of interrupts. So, thank you everyone for your patience. I hope you have enjoyed my lecture. Thank you.